Let us look at duplication formula. What is it? This is the duplication formula. Gamma of m times gamma of m plus half is equal to 2 to the power of 1 minus 2m times root pi times gamma of 2m. Now, how did we arrive at this? Let's derive this. We know beta of x comma y is equal to gamma of x times gamma of y by gamma of x plus y. And we also know that beta of x comma y is equal to 2 times the integral 0 to pi by 2 of sine to the power of 2x minus 1 theta times cos to the power of 2y minus 1 theta d theta, where x and y are greater than 0. Take x equal to m and y equal to 1 by 2 in the trig identity. Okay, so what happens? We get beta of m comma half is equal to 2 times the integral 0 to pi by 2 of sine to the power of 2m minus 1 theta times cos to the power of 2y is there. So y is 1 by 2. So 1 by 2 times 2 minus 1, which is 1 minus 1, which is 0. So we have cos to the power of 0 theta d theta. Now this is 1. So we are left with 2 times the integral 0 to pi by 2 of sine to the power of 2m minus 1 theta d theta. Now let's take this as I. So if we take this integral as I, we have 2i. Beta of m comma half is equal to 2i. Taking x equal to m and y equal to m. By the way, why are we doing these specific substitutions? Because here we have m and half. And here we have 2m, which is nothing but m plus n. So x and y are both m. So now if we do those substitutions, we get beta of m comma m is equal to 2 times the integral 0 to pi by 2 of sine to the power of 2m minus 1 theta times cos to the power of 2m minus 1 theta d theta. Now looking at the integrand, we have sine to the power of 2m minus 1 theta times cos to the power of 2m minus 1 theta. The exponents are the same, so we can combine. So we have sine theta times cos theta to the power of 2m minus 1. But we also know the trig identity. Sine 2 theta is equal to 2 sine theta cos theta. That means sine theta cos theta is equal to sine 2 theta by 2. So which means we can write this as sine to the power of 2m minus 1 2 theta divided by 2 to the power of 2m minus 1. Beta of m comma m is equal to 2 times, here we have 1 by 2 to the power of 2m minus 1. So this is a constant, we take it out, times the integral 0 to pi by 2 of sine to the power of 2m minus 1 2 theta d theta. Now here from denominator we take it up, we get 2 to the power of minus 2m plus 1. And we already have a 1 here. So we have 1 minus 2m plus 1. So that means we have 2 to the power of 2 minus 2m times the integral 0 to pi by 2 of sine to the power of 2m minus 1 2 theta d theta. Let's solve this integral by substitution. We have u is equal to 2 theta. Differentiating both sides, we get du is equal to 2 times d theta, which implies d theta is equal to du by 2. Changing the limits, when theta is equal to 0, u is equal to 0. And when theta is equal to pi by 2, we have u is equal to pi. Carrying out the substitution, we get integral from 0 to pi of sine to the power of 2m minus 1 u times du by 2. 1 by 2 we take it out of the integral and we take the interval back to 0 to pi by 2. So we end up with 2 times the integral 0 to pi by 2 of sine to the power of 2m minus 1 u du. So plugging it back in this, we get beta of m comma m is equal to 2 to the power of 2 minus 2m times the integral from 0 to pi by 2 of 2 cancels sine to the power of 2m minus 1 theta d theta. So here instead of u, we are writing theta because in definite integrals, the variable of integration doesn't matter what it is. So we change u to theta. Remember here, this I is this integral and this integral and this integral are the same. So we can say beta of m comma m is equal to 2 to the power of 2 minus 2m times I. Looking at this, we have beta of m comma half equal to 2i. That means I is equal to beta of m comma half by 2. This we substitute it here. So we get beta of m comma m is equal to 2 to the power of 2 minus 2m times 1 by 2 times beta of m comma half. Now here in the denominator we have 2. We take it up, it becomes 2 to the power of minus 1. Combining these two, we get 2 minus 2m minus 1. So now simplifying this, we get beta of m comma m is equal to 2 to the power of 1 minus 2m times beta of m comma half. Now we shuffle this around. We take 2 to the power of 1 minus 2m to the other side. So we have beta of m comma half is equal to beta of m comma m divided by 2 to the power of 1 minus 2m. When we take it to the numerator, the signs change. So we write it as 2 to the power of 2m minus 1 times beta of m comma m. Remember, we have gammas in the duplication formula. So let's convert both betas into gammas. So beta of m comma half is equal to gamma of m times gamma of half divided by gamma of m plus half equal to 2 to the power of 2m minus 1 times gamma of m times gamma of m divided by gamma of 2m. But we know gamma of half is root pi. So root pi. Now gamma of m on this side and gamma of m on this side, we can cancel. We can cancel because they are not equal to 0. So we have root pi times gamma of 2m cross multiplying is equal to 2 to the power of 2m minus 1 times gamma of m times gamma of m plus half. So we have substituted the value of gamma of 1 by 2 and we have done the cross multiplication. We require gamma of m times gamma of m plus half. That we have it here. So that means 2 to the power of 2m minus 1, we have to take it to the other side. Taking it to the other side, what happens? This goes into the denominator. When we bring it up, we get 2 to the power of 1 minus 2m times root pi times gamma of 2m equal to gamma of m times gamma of m plus half, which is what the duplication formula is. And here remember, m is greater than 0. To summarize what the duplication formula does is, if we take the gamma function at m and another gamma function at a half shifted value, that is m plus half, multiply them, we get something involving the gamma function at twice the number 2m. and hence we call it as duplication formula. In the next session, we will look at some additional identities related to duplication formula. Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.